Hi, so before starting the video, try to answer in the comment whether this graph represents the scalar field or it represents the vector field. Okay, so this is the 3D look of this graph. Okay, so predict whether it is a scalar or it represents a vector field. Comment below before starting the video, because in the video I have explained the solution. So you will change your answer according to my answer. Then you will say, yes, I knew the answer. So comment before watching the video. Okay, so whether it is a scalar quantity, scalar field, or it represents a vector field. Let's start the video. Hi, vector calculus is a part of syllabus of BSc Physics as well as BSc Mathematics students. Mostly all the videos available on YouTube for vector calculus are inclined towards BSc Mathematics. So in this playlist, I will incline the vector calculus to the physics, and I will cover animations, working models of vector calculus, and much more things. So consider subscribing as well as join my Telegram group. I am personally active there. Link is in the description. Hi. So in this video, we will cover a few basics of the vector calculus. For example, what is a scalar point function? What is scalar field? Vector point function, vector field examples, and animations for the all above explanation. Animation will be somewhat similar to what you saw in the previous few section. Okay. And some of the mathematical formalities are also important. So let's start. Now we know what are scalars, right? Right now in 2020, even class 9 students know the concept of scalars and vectors. Okay. So what is scalar? Scalar is any physical quantity. If any physical quantity has only magnitude, then that physical quantity is referred to as a scalar. For example, distance only has a magnitude, so it is a scalar quantity. Anything which has magnitude plus direction is referred to as vector. So if there is some quantity which has magnitude as well as it has direction, so it will be referred to as a vector. So my question is, what is current? Okay, what is current? Is current a scalar or it is a vector? Does current has magnitude? Yes. Does current has direction? Yes. So what is current? It is a scalar or a vector? Think on it. Okay. So what is function and field? Okay. Now if you ask a mathematician, think about it. Okay, what is current? Okay, so let me tell you, current is a scalar quantity because along with magnitude and direction, the physical quantity must obey triangle law of vector addition. Okay, it must also obey triangle law of vector addition, because for example, if current goes in a wire in this direction and there is some wire in which current goes in this direction, then I cannot say then the resultant current will flow in this direction. So this is the reason current is a scalar quantity. So what is a pressure? Think about it. Okay, so that is an assignment to you. Now let us define function and field. What is a function? If you ask a mathematician, sir, what is a function, then the definition would be completely different. Here I don't want to go into the depth of the definition. I just want to demonstrate the meaning. For example, I am sitting in a classroom and I have been given work to find the percentage of, suppose, 80 students. Okay, so I have to find the percentage of 80 students. Now what I will do? If I calculate the percentage manually, it will take lot of time, right? So what I will do, in my scientific calculator, I will create a function. Okay, it gives me an option to create a function. So suppose my function is x divided by 100 multiplied by 100. So suppose this is my function. Now once the function is created, I just have to put the values and I will get the answer. For example, if a student has scored 55 marks, so I will just put 55 in that function and I will get the result as 55%, right? Because 100 eventually get cancelled. This was just a basic example of just to explain to you the meaning of the function. So function is basically a template equation. What is a function? Function is just a template equation in which if I substitute the value of x and y, I will get a region around me. Okay, I will get a region around me. That region is referred to as field. What is that region referred to as? That region is referred to as a field. Okay, we will do everything in detail, don't worry. For example, now let us define scalar point function. Okay, for example, if I have a graph in my this section, this is the x and y axis, and my function is in this way. Okay, it is in this section. So the region occupied by my function, is referred to as the field. Okay, the region or the space occupied by my function is referred to as the field. Okay, now that field can be a scalar field if my function represents a scalar quantity, or that field can be the vector field. Now that is what we want to study now. So let us define scalar point function. Okay, so there is a definition: if for each point in space there exists a scalar, okay, there exists a scalar, or there exists a value, because a scalar is essentially a magnitude, that function is defined as the scalar point function. To be more precise, scalar field is a function that gives us a single value of some variable for every point in space. So that means, what is a scalar point function? That function will give me a value for each and every point in space. For example, this is my space, this is my field. So I will have some or the other value in each and every point of this space. So that is defined as the scalar point function. Now what is scalar field? The region occupied by that is referred to as a field, as I mentioned here. Okay, now let us take an example. For example, let us consider temperature. Okay, let us consider a temperature. Now for example, this is my room. Okay, this is my room. This is kitchen. Okay, and this is, say, balcony. Okay, so is temperature a scalar field or it is a vector field? Now in room, suppose I am, for example, this is room, this is hall. Okay, my question to you is, what is temperature? Is it a scalar or it is a vector? So for example, in hall there is an AC, so definitely temperature will be low. Suppose the temperature of the hall is, say, 16 degrees Celsius. Okay, in room, suppose the temperature is room temperature, 23 degrees Celsius. Kitchen is hotter because of the gas, so suppose the temperature there is, say, 30 degrees Celsius. In balcony, the wind air is there, so let us say the temperature is 27 degrees Celsius. So is temperature a scalar field or a scalar function, or it represents a vector? What is temperature? Now some students say, sir, see, if I have a this direction, so that means hall is in this direction, so their temperature is 16 degrees. If I say this direction, then this direction is room, then the temperature is 23 degrees. So temperature must be a scalar point function. Oh, temperature must be a vector point function. So no, this explanation is not correct. See, scalar point function does not means that every value will be same. Okay, see, we have a scalar. For example, I have a scale. Suppose a person goes from this point to this point, so the distance will be, say, 5 meters. Now that is single value, right? That is a single value. But a function is always multi-valued function. For example, I have a function. Okay, a function is always multi-valued. What is a function? For example, this is my function f of x, y, z is equals to xyz plus x square y square plus z square, for example. Now if I substitute any value, for example, I substitute value of all three as 1, I will get a new value. If I substitute the value as 0, 0, 1, I will get a new value. If I substitute the value as 2, 1, 1, I will get a new value. So scalar point function does not mean that it will be constant, that will give me a single magnitude as we used to get in 11th or 12th. No. Scalar point function means that it will have some value for each and every point. For example, in hall it is 16 degree, in room it is 23 degree, in kitchen it is 30 degree, in balcony it is 27 degree. So what is temperature then? Temperature is a scalar valued function or the scalar point function, and it represents a scalar field. I hope this covered your question. If not, then pause the video and think yourself. You will get the answer. Usually we consider scalar as just a single valued function, because in class 11th and 12th we have that option only, but here it is not like that. So what is temperature? Temperature is a scalar field. Now let's talk about the vector point function. What is a vector point function? Any physical quantity which represents vector, and if I have a function of that quantity, so it will be a vector point function. That means in each and every point I will have a direction. Okay, in each and every point I will have a direction. Okay, and the region surrounded by that function will be referred to as my vector field. For example, this is the vector field of two opposite charges. You can see this is the field. Okay, so this is the whole rectangular box or the square is the field, because I can see there is some or the other value and direction for mostly all the points in this space. So this is a vector field of two opposite charges. Okay, so I think everything is clear here. For example, if we want to see the mathematical formality, so I have a function here, f of x y z times I cap plus x square y square j cap plus z square k cap. It is the same function which we considered in the scalar. Okay, it is the same function, but just I am giving I cap, j cap, k cap. So now this will become a vector point function. Okay, this becomes my vector point function. I don't think there is anything much to explain. Similarly, this is also a vector field, right? It has some directions. Similarly, if I consider the earth, so and the universe, suppose the region surrounding my earth, so it will have also, it is also a vector field because gravitational force is there, right, which is directed towards the center. So what is this space around our earth? Is it a scalar field or it is a vector field? Yes, it is a vector field. Which vector field? It is a gravitational vector field, because there is a value as well as direction of force in every point surrounding the earth. So gravitational field is a vector field. Electrostatic field is a vector field. Magnetostatics, field created due to magnet, is also a vector field. Now let us define the scalar point function and vector point function with mathematical formalities. So if I have a function, say x comma y comma z, if I substitute some numbers in it, okay, so let us say I substitute the value 100, and in answer if I get a number, so that will be a scalar point function. For example, the same example which we considered, it is actually a famous example. Okay, that is why I am writing again and again this. So this function, if I substitute the value of x, y, z in numbers as this value or any value, what I will get in the end is some number, right? Because if this is 100, so this will be 0, because anything multiplied by 0 will be 0. What will be this? This will also be 0, this will also be 0, so it is 0. Okay, so what is 0? 0 is a scalar number, a magnitude. But if suppose instead of this I have this thing, okay, I consider this function I cap plus x square y square j cap plus z square k cap, and suppose I am substituting the value 1 and 1. So definitely I will get a vector, right? I will get this vector I cap plus j cap plus 1 k cap. So if I have a thing which is a function, if I enter my input and if in output I get a scalar, then it will be a scalar point function. And if in output I get a vector, it will be a vector point function, as simple as that. Okay. So what is this field? So this field is essentially a scalar field. Now those of you which guess that this is a vector field, mostly you will be looking at that, sir, it has some direction z. No. This is just a field, and you can see all the points in this. These are the points. There is no arrow given in this field. So definitely this field is a scalar field. Yes, it is a three-dimensional field. Okay, it has three directions. The field has three directions. But if you substitute any value, you will get a scalar, because there is no scope of direction. Okay, so what is vector field then? Let me introduce the vector field. Okay, so this is how a vector field looks. Okay, so you can see there is a magnitude as well as direction. See, the magnitudes of all the arrows are different. Okay, as well as there is a direction. For example, I will restrict this motion to the 2D. So this is the 2D motion. Okay, just a second. I may reduce the grid line so you can see clearly. Okay, so this is the 2D motion. Okay, this is the 2D motion. You can see this is completely represents a vector field. Okay, for example, now I want to calculate, say, flow of this field. Like if I consider this as a fluid, motion of a fluid. So I want to calculate that where my fluid will be flowing. For example, I want to calculate the motion of fluid at this point. So clearly I can see that if at this point I pour my water will be flowing in this way. I want to calculate my flow of water in second quadrant, so my water will go in this direction. I want to calculate my flow of water in this direction, so my water will flow in this direction. Considering here, anywhere if I pour my water, see, it will be going at this point. Okay, so this is the application of the vector field. See, you can see this illustration. This will be my direction of water flow. If I example, I pour my water in the fourth quadrant, then also my water will enter the first quadrant. Okay, so this is the impact of the vector field. I can do many applications such like that by using the concept of electrostatics, magnetostatics, but keeping simple, consider this as a flow of water. So definitely if I have mathematical tools from which I can calculate where my water goes, then definitely this is of some application in physics. Okay, so mathematicians just introduce the mathematical steps, but in physics it's our duty and responsibility to see the physics behind, like what vector field actually represents. So this is what vector field actually represents. In the coming video, we will be looking at the curl, where the curl is maximum, where the curl is minimum. We will be looking at the divergence, where there is more divergence, where there is less divergence. So stay updated. Okay, see you in the next lecture.